Okay, good morning or afternoon, students. Today is April 11th, Thursday. I'm sorry I can't be there. I'm in San Antonio at a science teachers conference, hopefully learning cool things to teach you guys in the future. Please be on your best behavior and act as if I was still in the room. For whoever is in your class today, they're giving up their valuable time to sit and learn some chemistry with you guys. So you guys have 3 minutes to do your STAAR flashcards. I'm going to start the timer on my clock, and then I will let you know when time is up, and we can commence with the rest of class. Okay, you have 3 minutes to finish both questions starting now. You have 2 minutes remaining to finish your STAAR flashcards. You have about 1 minute left. Okay, that's your time for the STAAR flashcards. Let's go through each of the questions. So the first one's talking about liquid nitrogen, which has a boiling point of 77 degrees Kelvin. And as they release it from its container, because they hold them in these big metal containers, they notice that they have ice forming at the top of the container as the nitrogen escapes. So they're asking for the best explanation of this observation. The first answer says that water at 0 degrees Celsius is colder than liquid nitrogen and freezes. Water at 0 degrees Celsius would actually be at 273 degrees Kelvin, so it's actually much warmer than 77 degrees Kelvin. So hopefully none of you picked A. B says that nitrogen boils and then cools to form a solid at the opening of the container. There would be no reason for it to cool outside of the container, seeing as it would be much warmer than 77 degrees Kelvin. Water trapped in the liquid nitrogen escapes and freezes. If there was water trapped in the liquid nitrogen, it would be frozen already. And D, it should be the answer. It says that the water vapor in the air over the opening of the liquid nitrogen freezes. So as the liquid nitrogen is escaping out of the container, the water vapor in the air freezes instantaneously because the liquid nitrogen is so cold. Okay, so hopefully you picked D. Okay, question 2. It's a density problem. It's a fairly simple one. They're asking if the block will float in olive oil, and then they provide you with the density of the olive oil. So if you look on your at your diagram here, you can see that they give you the dimensions of the box. So the first thing you should find is the volume of the box. So to find the volume of a box, you have to multiply the length times the base times the width. Okay, or sorry, the length times the height times the width. So the length is 4, the height is 4, and then the width is 1. So when you multiply those together, you should get 16. Okay, so when you multiply them together, you get 16. So density is mass over volume, and the mass is 15 grams, and the volume is 16. So when you divide 15 by 16, you should get a density of 0.937 or 0.94. Since that density is actually greater than the density of olive oil, that means it will sink, and the answer should be no, because it is more dense than the oil, because the density value would be higher. Okay, so hopefully you got both of those STAAR flashcards right. They are pretty simple ones. What you need to do now, you need to put your STAAR flashcard back onto your ring, and then hang them back on the hook, whoever the designated person is. And we're going to talk about what's happening today. So all you should need out is a calculator, a pencil, and the notes that you got when you walked in the door. That should be sufficient. So I'll give you about 30 to 45 seconds to get those things out, and then we'll be ready to move on. So I'll start my timer now. Okay, so that's been 45 seconds, so we should have everything put away and we should be ready to go. Let's talk about a little bit what we're doing today. Today we're learning about Arrhenius acids and Bronsted-Lowry acids and bases. We're going to do a quick warm-up on periodic trends. We'll talk about what is an Arrhenius acid, what is a Bronsted-Lowry acid. It's really just two separate definitions, so we're going to learn both of those definitions and then how to apply them. You guys will take a quick exit ticket over what we've learned about pH the last few days and over Arrhenius and Bronsted-Lowry acids. There's no homework for tonight, but tomorrow there will be a quiz on your STAAR flashcards. So you'll come into class, you'll grab your STAAR flashcards, you'll start quizzing each other, going over the concepts that we've learned. In the last 20 minutes of class, you will work on that. You have a test on solutions next Thursday, so that means starting all the way with what we talked about with solubility when we dissolved the sugar cube up until now. So it's a lot of material. We will review in class on Tuesday, but I was just going to put that on your radar for next Thursday.